Hello and welcome. Welcome, everybody. We're really excited to have you here today for our weekly OCI Deep Dive. For those of you that might be new to these events, we're hosted on Cloud Customer Connect, which is our Oracle community forum for end users. I'll share some resources for you throughout that will lead you back to those forums. And if you're not already a member, we invite you to join us, join in discussions, post questions, and look for upcoming events on all kinds of topics. My name is Kenna Kettrick. I'm a program manager with the OCI go-to-market team. And today we're joined by some very special guests. Lynn, VP at AMD Cloud Business Group, and Suresh Andani, Director, AMD Cloud Business Group. And also Matt Leonard, VP OCI Compute, and Jeff Browning, Senior Principal Product Manager at OCI. They're here to take us along on a conversation about how Oracle and AMD work together to offer you enterprise value and performance for cloud workloads. All right, I think that is quite enough from me, so I'm going to go ahead and hand it over. Jeff, it's all you. Take it away.
Thanks, Ken. I really appreciate it. So welcome everyone today to OCI Compute and AMD. We're excited to spend some time with you today to talk a little bit about how Oracle and AMD deliver really tremendous cloud value performance as part of our compute offerings at OCI. We're going to go through a little background of our partnership. We're going to get into some more details of some specific use cases of how AMD and OCI work together to deliver more flexible compute. And we're just excited to share the time with you guys today. So right now, what I'd like to do is hand it over to Matt Leonard, our Vice President of OCI Compute Product Management, to kick things off. Matt, the mic is yours.
All right, thanks, Jeff. Thanks for taking the time to join us today. I want to talk a little bit and give a bit of a foundation in Oracle Cloud and what we're doing to enable businesses. So we run everything from processing insurance claims, exchanging currencies on foreign exchange to critical crash test simulations and some of the platforms that we're using to host this very video conference today. These are things that are fundamentally important to customers' businesses. So it's important that they perform reliably and they're secure. Now, these are running on top of Oracle technologies. In some cases, they have been for many decades. And as we've built out Oracle Cloud, we're building on that legacy of 44 years, helping customers manage the world's most important data. That's why today more than 400,000 customers trust Oracle to help run their businesses. This includes 98 of the top Fortune 100 companies in the US. We value our customers and we want to continue to earn their trust every day. Our history is really important to us, and it's more important than it's ever been when it comes to cloud technology as the basis and the platform for your business operations. So with that foundation, it's important to us it's resilient, and we help you adapt and change to the constantly evolving needs of your business and your customers to prepare them for what's ahead. So companies have turned to Oracle because we've invested in helping them run their businesses. We've rebuilt our entire cloud business in order to ensure that we can help customers grow and evolve on OCI. We've made significant changes to the way our business become a cloud first and make our customers successful as they move to the cloud and beyond. We built modern SaaS services for all of our major business applications, and it goes from everything we've built from the ground up. It also applies to the applications that we've acquired, and we've rounded out our application suite. Unlike other enterprise software vendors, when Oracle acquires a new product, we rebuild it to make sure that it works and runs on our platform. And this includes integrating it into our Oracle Cloud Services as a SaaS application. We've built that brand new cloud infrastructure with more than 70 cloud services to provide unique value when running in the cloud so that our customers' applications, and most importantly, their enterprise applications, run smoothly. So as a vendor with a complete suite of integrated cloud applications and next generation infrastructure platform, we're in a unique position to deeply understand the challenges that enterprise face when they're moving their workloads to the cloud. We've dedicated our engineering and infrastructure resources to ensure that we have a wide range of flexible and simple options to help you run on OCI. And when that comes to compute, we'll talk a little bit about how we've adapted the way that we deliver compute to customers to ensure that you get the best, highest performance, consistent, reliable running on OCI. So beyond our innovations in how we provide flexible compute options, which we'll dive into in a little bit more detail, we want to help customers with their workload needs. OCI needs reliable and trusted strategic partnerships with leading providers like AMD. So with that said, I'd like to introduce Lynn, VP of Cloud Business Solutions at AMD.
Thanks, Matt. It's great to be here.
Thanks. It's really great to have you here, Lynn, and continue our relationship. We've been working with AMD since 2017 when we launched our first AMD shape, the E2 powered on the Naples processors. Since then, we've had tremendous amount of customer interest and adoption with a wide array of customers from media and entertainment to financial services and government customers. And the story with AMD just keeps getting better. We've gotten a broader and deeper collaboration supporting a broad spectrum of customer workloads, but Oracle uses AMD internally to deliver some of our SaaS offerings. We're expanding our portfolio of AMD-based virtual machine offerings on OCI. So today, we offer flex compute on virtual machines and bare metal instances. The latest generation is powered by AMD's third generation EPYC processor running on the Milan-based CPU. And we're excited to be here talking about that today. So, Lynn, one of the things that really separates OCI is AMD's great performance. Can you share a little bit about the significant gains that AMD's made over the last few years?
Sure, I'm happy to, Matt. Thank you so much for inviting us. We are so pleased to have developed such a strong partnership with Oracle Cloud Infrastructure over 3 generations of EPYC processors. And our goal together has been, how can we deliver outstanding performance and value to our joint customers? One way that our customers think about the value from AMD is what we call time to value, because we have a lot of people that are saying, hey, I have to do more, I have more data, I've got to get things done faster. And that translates for them into better business decisions. And so with the EPYC 7003 processors, that just continues the architecture innovation of our prior generations, and it brings a 19% uplift. So the customers of Oracle and AMD together can get their answers and their results faster, and they get stellar software performance. And great example of this is a commonly used Redis database, which is a scale out workload. And we've had customers that have said they see as much as a 30% performance improvement relative to VMs that are featured in our prior generation. So we want to keep pushing the envelope and do that with Oracle every single generation. Now, Matt, one thing that we should talk about as we're advancing these innovations is compatibility to run the common workloads.
Yeah, thanks, Lynn. You're absolutely right. Like, on the AMD-based shapes on OCI, they're fully compatible with any x86-based application of workload. So for us, what that means is whether you're using bare metal shapes or virtual machines, which we're talking about today, you can count on them to run smoothly and efficiently, regardless of where they run. So that ability for x86 workloads, basically out of the box, makes it simple to get those performance gains. And with OCI, the cost savings that you're looking for your workload.
And from the AMD perspective, our processors are built on the x86 architecture, and that's been the architecture of choice for decades for the commercial software vendors and operating system. And so virtually every single application is going to run seamlessly out of the box on AMD EPYC-based VMs, and that really means that you can enjoy the gains of EPYC without any disruption to your business.
Thanks, Lynn. I mean, one of the other areas we wanted to touch on was our organization's alignment with sustainable computing platform. You know, this isn't a new thing in the industry, and it's certainly not new for OCI. It's an ongoing investment for us. You know, in 2019, 59% of the electricity that we use to power Oracle Cloud was certified as renewable. Today, we are at 100% in some of our cloud locations, Frankfurt, London, and Amsterdam, but our goal is to be 100% renewable energy by 2025. So beyond the power sources, it's critical to make sure the power is well used. And that's where partners like AMD come in. Lynn, I know you have some aggressive goals over at AMD for reducing power usage. Can you share a little bit more about AMD's approach to responsible computing?
Absolutely. AMD has been very public about our commitment to being the energy efficiency leader among x86 processors. And one example is our goal to improve the energy efficiency of AMD processors and accelerators for AI training and HPC by 30x by 2025. Now, to give you an idea of what does 30 times better mean, we're looking at this in terms of an over 51 billion kilowatt hour of electricity, and those savings could be recognized in 2025 if AI and HPC server nodes globally make similar gains to what we've committed to with our processors at the 30x by 2025. Now, that's a big number. What does that really mean? It translates into about $6 billion saved in electricity costs, or over 36 million metric tons of CO2 equivalent. Now, that translates into electricity generated by over 7,000 wind turbines in a year, or one of my favorite metrics, 600 million tree seedlings are grown for 10 years to get that same equivalent. Now, what I'd like to do is just give you a sample of the architecture that is being used to reduce the power usage, but it does some amazing things while it is incredibly efficient as well. So one of the things that we're really excited about, besides the performance per watt, which translates into those energy gains that we just talked about, is this chiplet and 3D stacking architecture. We've been working very closely with our suppliers over the last few years, and that has allowed us to combine chiplet packing with die stacking. And this 3D chiplet is a really, really interesting architecture. It's got 3D vertical cache, and it gives you a much denser integration and much better efficiency, which allows us to bring some of those 30x gains that we just talked about. That improves the thermals, the transistor density, the interconnect pitch, and it only requires 1/3 the energy per signal of other approaches in 3D. The other thing that we also are really focusing on is dynamic power management and the I/O logic that allows you to balance power consumption and performance. Sometimes power balancing really comes down from finishing workload as fast as possible and going into idle, and sometimes not. So the dynamic aspect of that allows certain I/O workloads to benefit from disabling the power management, so you need performance, or if you're really focused on energy efficiency, you can turn that on. So it's really, really flexible and allows you to basically get whatever operational mode that you need. Along with that, we've got leading core counts for x86 processors. And our goal in this is to allow our partners like Oracle and OCI to build denser, more of energy efficient servers. Back to you, Matt.
Thanks, Lynn. So one of the things we wanted to touch on, and I appreciate the investments that AMD is making in helping us build a better cloud platform, right? Like the innovations from AMD with increased density on cloud services allow us to design data centers that are custom built to deliver compute capacity to customers, which brings us to a story about the evolution of cloud that we like to talk about, which is looking at like where we are and where we're going. So in a traditional on-prem data center, you're somewhat inflexible. You have a budget for peak workload, and what you end up with is either wasted space or wasted compute or wasted power, right? Like in a traditional data center, you tend to have waste because everything's in fixed ratios that are pre-provisioned, whether it's storage or networking resources. Early generation cloud really kind of took that notion of data center and made that a service where it costs less, provisions faster, but it's not truly elastic. It doesn't deliver on the ultimate promise of cloud, which is flexible compute. So with flexible infrastructure, you can provision compute, block, and load balance to meet your needs and update them as you evolve. So where OCI is going with flexible compute today, we've evolved to the point where we allow you to configure the amount of compute that you need for your workload to meet exactly your needs, to match your workload needs. Where we want to be in the future is that we'll allow you to dynamically resize the amount of compute that we deliver based on what's going on within your application, so that you can horizontally or vertically auto-scale that workload within seconds and only pay for what you need. So when we're looking at a wide range of applications that are deployed today, they're simply not built the same. Primarily, they rely on a diverse collection of underlying purpose-driven software and technology required to deliver these modern solutions. For instance, some applications, such as real-time video encoding, AI, ML, complex simulations, and many other compute-intensive software, are inherently processor-bound. The software that delivers many of today's e-commerce and transaction logging applications run on database and run best with like high memory allocation to support the design. Adding to this complexity, some applications are spiky. They horizontally scale. They don't have standard or stable utilization profile. And finally, in almost every scenario, there's an increased cost and ROI expectations that you're expecting to get from your cloud provider. To adapt and respond to this range of differences in application and workload needs, OCI is focused on building flexible compute. How do we create a simple compute offering that makes it easier for you, our customers, to deliver high-performing, cost-efficient solutions? That's when the notion of flexible compute comes in. So if you look at traditional clouds and how they package compute, memory, and compute, they deliver it in fixed shapes. So for example, customers can choose 1 to 8, 4 to 32, or 8 to 64 allocation of resources. And tied to that as well is access to other resources like block storage, networking, load balancing. So based on the design of the underlying hardware, you'll get balanced consumption, but it really is tied to like how the cloud provider designed that hardware itself. So the notion of this pre-configured compute where customers have to choose, and where they increase one dimension, it increases at the same ratio all the other dimensions of that compute instance, results in over-provisioning and obviously increased cost and waste. And that waste is obviously waste that you pay for. It's waste that we, the cloud provider, pay for. And it's waste that like is consuming resources as well. You know, and when we look at our footprint and trying to reduce waste, our goal is to ensure that like we deliver only the amount of compute that you need in order to power your workload. So our answer for that, flexible compute. So our innovative approach to compute resource allocation puts you in control of the amount of CPU and memory that you configure on an instance in the shape. So at the start of the project or throughout the life cycle of your workload, you can reconfigure that shape to meet your needs. OCI Flex shapes allow users to configure core to memory ratios from 1 core to 1 gig, from 1 core to 64 gig per core. We also allow you to build on top of that with things like burstable instances or preemptible. And in burstable, maybe you don't need the full CPU all the time. And so we allow you to set that at a half or 1/8 of a core, and that will auto scale up as needed when you have burst within your workload. On preemptible, when you have ephemeral tenancy needs and you can afford to be fault tolerant or interruptible, we allow you to flex based on the time. And then obviously being able to flex the shape of your machine to meet the type of workload that you have, whether it's media encoding or in-memory database, you can take advantage of that same underlying compute system. We don't want you to be forced over provision. And so, for example, in our AMD E3, which is based on the Rome-based processor, one OCI shape is the same as 39 different shapes on AWS, for example. That simplicity translates to you as the consumer. It's less shapes that you need to qualify. It's less waste for your workload, and it translates into cost savings that directly impact your overall cloud TCO. Flexible shapes make it easy and simple to flexibly run the cloud the way that you need to. So related to that is our philosophy around pricing, and it's important. We would just want to keep it super simple. OCI compute instances are priced the same regardless of where you run them. You shouldn't need a PhD in billing in order to understand and price the cost of your application and workload. So it doesn't matter whether you're running a burstable instance, whether you're running a preemptible instance, whether you're running a bare metal or a virtual machine, or coming soon our container instances, it's the same simple price based on the core and memory. You can run it in London, you can run it in Frankfurt, you can run it in Virginia. It's going to be the same simple price. And that's our philosophy. We want to keep it very simple for you. And lastly, we wanted to talk about coverage. Oracle Cloud's available today in 37 different regions, and we're rapidly building out new regions. Our goal is to give you proximity, data sovereignty, and true disaster protection with multiple geographically distributed cloud regions in every country. Oracle's cloud serves a variety of commercial business, government sector, and on-premise solutions to meet the needs of your business so that you can grow and scale with Oracle Cloud. This range of options is going to allow you current and future use to scale in OCI. With that, I'd like to introduce Jeff Browning and Suresh Andani. We're going to talk a little bit about flexible shapes and give a few examples of how you can unlock great performance with savings.
Great. Thanks, Matt. Really appreciate it. And thanks, Lynn. Some really exciting insights into how we've been working together for a long time with AMD. So excited at this point now to, along with Suresh, jump into some actual examples of how flexible instances built on AMD processors really can change the game for our customers in terms of how you can get improved price performance with your compute. So the first example we want to look at is how flexible shapes can really change the game for what we call memory-intensive workloads that Matt mentioned earlier. If you look at this traditionally, on the right, you can see a fixed shape with ratios that are commonly available out there. But if you really look at the sweet spot, the shape on the left, this is really kind of a unique shape, 4 cores to 112 gigabyte of memory, where it's loading a lot of memory, or providing a lot of memory for that database to run most efficiently with the most optimized performance. What's exciting about the ability for flexible shapes to be able to, in this scenario, be optimized or tuned to extremely higher amounts of memory means that you get exactly what you want with a flexible shape and nothing that you don't need or that you don't want to pay for in a fixed shape. Now, another interesting thing too is because software licensing is commonly tied to processors, you also get savings from a standpoint of software licenses in this scenario as well. So let's take a deeper look here at an example, and I want to pass over to Suresh. Suresh, I'd love to have you kind of walk through an example that we've been working with you guys on in terms of e-commerce applications. So I'll hand it over to you, Suresh.
Okay, thanks, Jeff. Since we're all so data-driven in today's world, let me take the audience through an emulated scenario of an e-commerce application that benefits deeply from the OCI Flex Shape offerings. Today's digital economy, it is not uncommon for a medium to large-scale global retailer to receive 70 million plus page views daily to its e-commerce site. Whether shoppers are looking for bestsellers in a given category or sorting the products by ratings or price, this could easily translate to more than 500,000 transactions per minute. These transactions need to be performed in near real time with high concurrency. Seasonal traffic and highly variable shopper patterns make it challenging to predict the appropriate amount of compute and storage needs. Next slide, Jeff. Oops. Some delay, sorry. All right, so now let's look at 2 options to implement a database management solution for the e-commerce scenario that I just discussed. The dataset size to store all product entries in a relational MySQL database could easily sum up to 100 gigabytes compressed. The 2 options to implement MySQL database management here for this e-commerce scenario are, number 1, you could use a fixed aka t-shirt sizing. Here you have 2 sub-choices. A, choose a fixed general purpose VM with 1 vCPU to 4 gigabyte RAM ratio. This is the second red blob from the left that you see on your screen. While this is cost effective, it does not meet the 500,000 transactions per minute SLA or performance that is required for good end customer or consumer experience. Another option is B, choose a fixed memory optimized VM with 1 vCPU to 8 gigabyte RAM ratio. This is the rightmost red blob that you see on your screen. While this meets the 500,000 transactions per minute performance requirements or SLA, you can see that it is not very cost effective as the workload is not really memory bound. The real optimized or Goldilocks zone here is the Flex instance, where you can choose a 1 vCPU to 6 gigabyte RAM ratio. It gives you the required performance of 500,000 transactions per minute at 8% lower price point compared to memory optimized fixed instance. If you multiply the 8 to 10% savings on one workload with hundreds of workloads that a typical mid to large scale enterprise runs, the TCO savings add up significantly. And you can channel these savings to build better applications to grow your business versus wasting it on the infrastructure that you do not need. Okay, so hopefully this exemplifies the benefit that OCI's Flex instances running on AMD. Back to you, Jeff.
Suresh, thanks so much. A great example of how flexible shapes optimized for, say, memory allocation can literally save almost 10% instantly in that scenario and return right back to the bottom line. Great example of flex for memory optimized applications like databases. Now let's kind of swing the pendulum the other way. And let's take a look at another type of flex instance or flexible shape, in this case, for compute intensive workloads. These type of workloads in many cases don't really require as much memory. In this example, we're going to talk about being able to choose a configuration that's highly compute intensive is really kind of unique and kind of something that's focused on this. And video coding, which requires significant crunching and processing, requires a significant greater amount of compute, but not as much memory. So if you were to use a fixed shape, for instance, here, you can see the red outlined here. These are areas, if you used a fixed shape, you would be paying overhead effectively for things you just didn't need. And that's waste that not only is unnecessary from a budget perspective, but simply takes up more capacity. And so what I want to talk about now is a customer of ours that's actually used AMD-based flex shapes with an OCI to deliver better, more performant and cost-effective video encoding using flexible shapes. So let's take a look at Phoenix Real-Time Solutions that are based in Chicago, and they're driven to deliver a better entertainment experience for folks online. Entertainment companies and sports leagues know that the social aspect of sporting is really significant, and it's simply a lot more fun when viewers can share their reactions right in the moment. And that's unless somebody sees a soccer goal or an awards show announcement 30 seconds before, or their friends do, and then ruin it by live tweeting or sharing it in social media. Phoenix addresses the challenge for event broadcasting by using their own code, their own real-time streaming technology, but they also deliver it utilizing flexible instances that make sure everybody enjoys the same instant real-time activity without the frustration of buffering, delays, and spoilers. And an interesting stat, 28% of sports fans out there watching a game or event will actually drop after encountering a single problem with their streaming experience in video. And so what's exciting here is Phoenix Real-Time's code lets users watch real-time content in the same frame at the same time, regardless of device or operating system. And this is all delivered utilizing OCI. Now, using the cloud, Phoenix, interestingly enough, was able to, using OCI Cloud and our flexible compute shapes, we're able to stream a global TV awards program to millions of internet viewers 100 times faster than the network itself could deliver them, and also with half-second latency compared to almost 93-second latency in the alternative approach. At the same time, we talk about price savings. Compared to other services the company tested, Oracle Cloud and Compute using Flex Instance reduced costs for processor-based workloads by 40%, and lowering the expense of delivering the streaming data by 70%. And so when you look at this is a fantastic real-world example where for a compute-intensive flexible shape, OCI Compute and AMD have been able to help deliver significant value for one of our most valued customers. So Suresh, first off, maybe a few quick questions here. First off, with some of these scenarios, what really stands out to you about some of the things we've talked about today with OCI and AMD in terms of flexible instances and shapes?
Yeah, Jeff, I think what stands out particularly for me is the simplicity at which the flex shapes provide the flexibility to the end user. It's very difficult if I'm in DevOps to really predict, like for my application, what is the exact need for my compute, for my memory, for my storage, things like those. And what happens more often than not is most of the DevOps folks end up selecting t-shirt size fixed shapes that either are under provisioned, which impacts performance, or over provisioned, which adds cost. And the biggest challenge, if you look at all the surveys recently from the big market research companies, the biggest problem, the biggest issue that the cloud adopters are trying to solve is how can I really optimize my infrastructure costs. And for me, what really stands out with the flex shapes is it gives you the granularity of 1 vCPU and 1 gigabyte of memory and even more. That really takes off the guesswork and over provisioning / under provisioning out of the equation, and just giving you the flexibility, reduce the wastage, and given, like I think Matt had a really good slide earlier that shows that just one shape can really translate to dozens of fixed shapes, and it's really simple. So that really stands out for me, Jeff. And I'm sure that there are a lot of customers we know of mutually, but also within OCI, within Oracle Cloud, the services that benefit. So Jeff, are there any examples of how the customers or even Oracle and its internal properties use flexible instances?
Yeah, it's a great question and great points regarding finding right fit for applications. I think you nailed it. I think that's absolutely the case. And it's interesting, you know, Flex is incredibly popular for that reason. Nearly 60% of our customers out there using AMD-based compute are using Flex in some way or another. That's a lot of different customer usage scenarios where people are using it primarily because it provides, like you said, a really simple, flexible way to really dial up or dial down the price performance to match the either the technology requirement or the business requirement. And it's very rare to be able to get that real kind of fine-grained control to match business needs to technical requirements, right? And so basically, we've got just a bunch of customers out there that are doing it, kind of getting it their way, right? You get it their way and run their workloads their way, anyway, anytime, anyhow, wherever it may be deployed. So there's a lot of them. And that, again, swings people running, you know, in-memory databases and very significant environments, all the way to some of these more compute-intensive AI/ML and other types of applications as well. And as far as Oracle goes, you know, we're one of the benefits of OCI is that we are an application operator as much as a cloud provider. So we have a lot of scenarios where we're using very similar technologies, databases for sure, right? In terms of being able to scale those and using, and they'd use predominantly AMD technology to support that. So in many cases, AMD and Flex are popular with Oracle, you know, business units, whether it's our business suite or other applications and platforms we run. So we're not just a vendor and a company that provides cloud and encourages people to use AMD. We use it quite a bit ourselves internally and increasingly more over time. So it's a big part of our business. So now, Suresh, maybe one more quick question.
I just add to that last point. Yeah.
Yes. Go ahead. Yeah.
Suresh, just building on that thought, you know, like thanks to AMD, you folks are driving down the cost per CPU, right? And we're seeing that with increased density allows us to pass those savings on to our customers. One of the things that's still relatively consistent and common is the cost of memory, right? And so, like, depending on your application topology, the amount of memory that you need and the ability to tune that memory can significantly decrease your costs. And so we have examples like a large telecom provider running on OCI that saw as much as a 30% reduction on a multi-million-dollar bill by tuning the amount of memory for their application using Flex Compute. And so for me, that simplicity and that ability to tune the memory as the CPU prices are driven down by our vendors allows customers to realize significant savings. And that to me is the power of Flex Compute when it comes to the TCO, right? Like you don't just get the performance benefits, but you also get a massive TCO benefit by tuning into that workload. So sorry, Jeff, to interrupt.
No, that's a great example, Matt. Thanks. Yeah, I mean, there's just a ton of things where there's significant savings customers are gaining by basically being able to tune this much more granularly to meet their business needs and technology requirements. So great point. So Suresh, we have a few minutes left before we wrap up. You know, maybe tell our folks a little bit more kind of what's in store at the future of AMD and what are you and your team seeing in terms of where there's going to be more increased innovation and activity moving forward?
Yeah, I think there are three main pillars. Actually, let me say four main pillars, tenets, based on which we have drawn our vision, right? So the very first one, we want to continue to be the throughput per socket and performance per core leaders. That really drives the lower TCO that Matt alluded to earlier. It is very critical for enterprise IT applications, which are always under a budget crunch, to really get the best and most out of their infrastructure. So making sure we continue the core density per socket leadership and performance per core leadership is one of those pillars. And as you see, our current products that are leaders in core density and performance and throughput per socket, we're going to be introducing the next gen products, which builds on that and further increases AMD's leadership on throughput per socket and performance per core. The second one is about share performance in high performance compute applications for accelerated computing. So again, the kind of the number of cores we pack in one socket, the amount of L3 cache, the memory bandwidth that we have now. We have been leaders of having the highest memory bandwidth per node, and we're going to extend that in the upcoming products. Those are very critical for high performance compute applications such as computational fluid dynamics in manufacturing industry, such as oil and gas, such as weather forecasting, government and public sector. So we want to continue kind of driving that because we have a clear leadership here in the HPC space that we want to kind of continue to grow. The third pillar is about sustainability. We talked a little bit earlier, and having the performance per watt advantages driven by the architecture that Lynn kind of walked us through. Adopting the fastest technology node, be the first to a technology node, having the dynamic power management features and kind of investing more in that area is critical. As more and more governments kind of have regulations about how much power a node could take and how much power a rack could kind of dissipate, it is very important for vendors like us, AMD, to provide to our partners like yourself that advantage that kind of reduces the power consumption at the source. And then when you layer on top of it the renewable energy, the water stewardship, all the commitments that you have, it really puts a highly sustainable product out in the market. And it's not just sustainability, is not just a, it used to be kind of an afterthought or a luxury. It is a requirement right now. So we want to make sure that we are kind of building products that helps you guys meet your sustainability goals while also helping us meet ours. And the last one that I want to talk about is about confidential computing. We have a unique architecture around confidential computing, the way we kind of manage confidential computing and security, which is ingrained within the SoC. The keys managed within the SoC. It's a very unique architecture where you can take your current applications and lift and shift with just a push button to make them secure by design. So again, just to wrap it up, continue the TCO leadership with the core density that we have, continue the high performance compute leadership per core, sustainability, and security in the cloud. So we're investing heavily in innovation in these areas. And as a result, we are seeing more and more partners, but not only partners, but end customers adopting AMD technology in the cloud.
Fantastic. Wow, Suresh, great kind of insight into kind of the way AMD is thinking about things and the road ahead. So great. Thanks for sharing that. Fantastic. All right. So let's go, let's take a few minutes, share some details about how folks that want to learn more, that are tuned in, that want to be able to learn a little bit more about how they can get started, right? How they get started with flexible shapes and OCI using AMD. A few things here, both from Oracle and AMD, plenty of resources for researching and evaluation. One of the first ones, and I believe the links will be posted in the chat for folks as well. First one's the oracle.com/cloud/compute website. A lot of great resources there as well, including links to the most recent E4 announcement that shows some of the interesting performance parameters and capabilities of the E4 instances running on AMD. There's also some great resources, Suresh, that AMD's put together as part of our partnership as well. Do you want to share a little bit about that?
Yeah, absolutely. Thanks, Jeff. Yeah, there is, you can find it on AMD website. There's 5 reasons why AMD EPYC processors in Oracle Cloud. So a lot of it, what we discussed, is kind of captured in more details in this nice paper that you'll find on amd.com, and the link is posted right now in the chat window. Thanks, Kenna, for that. The other one I would like to draw your attention is a arena training. This is a kind of instructor-led, like it's on-demand kind of training that we put together. If you're not a reader kind of a person, you can go and look at this training, which basically does a voiceover a lot of those concepts. That's the one in the bottom. And on the top right here is our latest. So AMD works very closely with the OCI engineering team. We have benchmarked some of the very critical and used workloads, such as databases, media encoding, some analytics, and the benchmarks. So basically compares the previous E3 generation, which were built on Rome, and to the latest E4 generation built on Milan processors, and it shows the performance uplift we are getting on E4. So great resources there from both Oracle Cloud as well as AMD here for you guys to go take a look at it offline.
Yeah, and Suresh, just to add, the last paper you mentioned is fantastic because it not only talks about just kind of standard hypothetical applications, but really some interesting both database, more encoding based. There's a bunch of interesting examples in there, I think, that really illustrate the performance gains and opportunities there. So fantastic. Well, with that, I want to take just a moment to thank Lynn. Thank you. Suresh, thank you for joining us today. Matt as well, thanks for joining us. It's been great to have an opportunity to share some details and insights about how OCI, working in conjunction with our really valued partners with you guys with AMD, to be able to deliver this really interesting flexible compute capability that just delivers more value for customers. And we really appreciate taking some time to share your insights and talk about this with us today. And hopefully we'll be able to do this again sometime soon.
Thank you, Jeff.
Thank you.
Thanks, Lynn. Thanks, Matt.
Thank you for taking the time to talk to us.
Yeah. Ken, are there any questions that we should kind of, from the audience, that we need to go over here?
I don't see any coming through yet. I don't know if there were some other ones that came through earlier, though, if anyone has those marked. I don't see any fresh ones at the moment.
Let's see here. I don't see the immediate ones. Nope, nothing current here that hasn't been answered.
Okay. Well, we will be sharing this out. There will be replays, and all the resources that were mentioned are going to be shared out with those as well. So hopefully folks will have more opportunity to dive in and learn more about everything that you talked about today. And I just want to echo Jeff's thanks. Thank you everyone for joining us. Thank you to our audience for joining us to listen in. And really appreciate all of your time today.
Thank you.
Thank you.
Have a great day, everybody.